Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. Hopefully, you are all in good health. Um, Still with this subject until the end, those who are left or drop. Um, Maybe I would like to encourage you to take this subject because you may get a lot of knowledge from this computer vision subject. I'm very sorry not to have a class on last Monday because a bit busy this week. I'm not sure whether you are lucky or unlucky having me because sometimes busy. But I think I can share you experience what I'm doing instead of just become a lecturer. I'm also doing some project with the industry. Um, um, I've been given by one automation company in Kuala Lumpur, in Subang to be exact. This company got a project uh, to set up a production automation production line for Perodua, uh, for the car, for automotive, for the Beza and also Myvi. So this company partner with me. Um, uh, they give me to help them on the vision inspection station. I can share with you one um, one photo. So what we are doing for the um, Perodua, you know, Perodua project. Let's see. This is the photo. Where is the photo? Okay. Um, Wait a minute. Let me check. No media. I see. Where I put this. Never mind. I will share with you later. But basically, I wish to share with you my experience doing some project in industry, particularly on machine vision, which is related to the subject. Okay, for the today we for this video, uh, this is the video. This is a video for chapter 2. We done on the chapter 1. So you can go to Kalam and download or watch the video, get the link for the video chapter 1, part 1 until part 4. And then you can try the exercise because maybe next week we're going to have a quiz. So you can do the exercise 1. Okay, so just play around with the exercise so that you can get ready with the quiz maybe by next week, inshallah. Okay, let me open the slide uh, so that I can give lecture on the slide on chapter 2. So this chapter 2, we go to the fundamental or theoretical of the computer vision system because the chapter 1 is just for the introduction. So for this chapter 2, there are 81 slides, maybe 2 or 3 parts of video for the chapter 2. Okay, so this is the digital image fundamental. Um, um, Chapter 2. So you need to have a fundamental of image processing. If you are happen to be engineer which is taking care of the machine vision system, then you need to have the fundamental of image. If you want to develop a system for machine vision, you don't have to have basic programming. I mean, um, basic programming means that you write a coding from scratch. You write a coding from zero, from start from zero. If you go out and work in industry, normally for the machine vision, for the image processing, for the computer vision, there are a lot of ready software, which is you don't need to go for the basic programming. Ready software means that everything is available. It is like you want to cook. Um, you want to cook a dish, right? So you don't have to start from tech, finding um, all the ingredients. Uh, Sometimes everything is ready, 3 in 1. So you just take it, put some, find a hot water, get the Nescafe 3 in 1, put it in the water, stir, and then you can drink. Okay, so you don't have to find a Nescafe, to find a sugar, to find creamer or whatsoever by yourself. Uh, Everything is ready. So that is the what you call third-party software. It's easy, but you still need to have a digital image fundamental. Okay, if you don't have fundamental, it's a bit difficult lah. Although everything is ready, right? Sometimes when you cook, but you don't have a good fundamental on the ingredient, although everything is ready, but sometimes uh, the dish that you cook is still not feel well. Okay, not good. So at least you need to have fundamental. Then you have this kind of third-party software, which is everything is ready. So um, it can be done in a short time. Okay, but if you need to do it by start from scratch using basic programming, C for example, it may take time and you have to think more because you need to know all the fundamental of the programming. So it's up to you, and it depends to the working environment later on when you graduate. If you become a developer, right, programmer, and then you have to program lah. But if you are a user and work with industry, and your boss asks you to develop a system, so just tell your boss that you want this third party software. So it's easy for you. It's very fast, and perhaps you have the fundamental. So that's why digital image fundamental is very important, because once you have the fundamental, then it's easy for you to develop a system. So this is the digital image fundamental component of vision system, element of visual perception, image representation, basic relationship, visual image introduction to mathematics. Okay, 3, 4, 5 is important. 1, 2 is just general knowledge. 3, 4 is close related to the fundamental of digital image. So digital image is actually it's like human visual, human visual. We visualize system. Then we want to we want to we want to study how our eye or brain interpret an image. Okay, because we want to replace human, right? For example, uh, for a certain task, right? We rely to a human, and then we can replace the human by a machine. Then we have to study how a human look at the object, work, the task, everything. Then we design a system that can perform like a human. So that's the idea. So this mission vision is actually looking at the human visual system, right? So this is the structure of the eye, the human eye. So you can read the slide: brightness, adaptation, and discrimination. So just read this one for your general knowledge. Okay, so this one also uh, just read the slide. Okay, but I would like to explain here. Um, I would like to explain here. Let's see. Um, okay, at this slide. So this is an image, but when you see this image, um, your brain can interpret more, right? I mean, you see this is black object, you know, but when this black object arranged like this, your brain translate and your eye see this. That is like square, right? So that is the gift, you know. But if you develop a machine, of course, it's difficult, to interpret this box, because machine maybe just looks this black only. It can be done, but need to have intelligent methods, so that the machine also can think like human. So same like this, you can see the circle, the brain, our brain. Okay, so that's the idea. Okay, so this is another one. I also would like to explain a little bit here. Light and the electromagnetic spectrum. Light is just a particular part of the electromagnetic spectrum that can be sensed by human. The electromagnetic spectrum is split up according to the wavelength of different form of energy. So this is more to the physics, but it is actually based on this fundamental. Then we get the camera. We get a camera. People invent a camera based on this theory lah, wavelength, spectrum. But for us, we are not interested on this on the invention of camera. Unless you are interested, then you have to go for the other subject lah. But for this one, it is more to the implementation lah. It's not the basic of the camera, invention of the camera. But it is important to know this theory about the wavelength, because as you learn the electromagnetic theory, so this is the theory of the electromagnetic, or wavelength. We call it wavelength. With this wavelength, uh, we can see an image, something like that. The in easiest way to explain it. So the image that we see is actually in this range of wavelength. We call it visible spectrum that can visualize. So this is the wavelength, right? If you see red, the wavelength is 600 nanometers, 400 nanometers up to 700 nanometers. When you have this wavelength, you can see, you can visualize, which is, we call it visible spectrum. So we have the other spectrum, 300 nanometers, gamma rays, UV, ultraviolet. Then you have infrared, microwave, television, and radio. So for this computer vision or image, is actually fall under this wavelength, 400 nanometer up to 700 nanometer. So if the wavelength less than this, you cannot see. It may be infrared, because infrared you cannot see, right? I mean, if you can see the red, but it is not giving you any information. It's not like visible. You see the object. You see the car, for example, image. Okay, so all these wavelength have their own function, or we can use for a certain work or certain purpose. Gamma rays, X-rays, UV, visible spectrum, infrared, microwave, television. Okay, very interesting. Okay, so this one you can read. So this is all the theoretical. So this is the imaging outside the visible range. Image is visible spectrum, but other wavelength is useful for the certain application. Then that application also we want to visualize. That's why they call it imaging outside the visible range. Gamma rays, X-ray, and X-rays. X-ray is not visible, but you can visualize it. But of course, you can't visualize like RGB, red, green, blue, but still can see lah. It's generate from the energy that reflects, generate image. But the image is not like art, doesn't have colors, kan? Ultraviolet, infrared, MRI. So this is all the imaging outside. They can get the image, but it's not visualized the real one like you can see like humans. So back to the image processing. When we capture any image in this wavelength range, then we we want to process it. Like human eyes capture, go to brain, and brain can process. So this is the same thing. That's it, the same concept. Components of an image processing: image displays, computer, mass storage, hard copy, specialized image processing hardware, software, sensor, and problem domain. If you have problem, image sensor, use camera, and then use software or hardware, software to process it, computer, and then do decision, go to back to the network. So this is actually the operation of image processing. You have image, you perform some operation, you get image. You have image, perform some operation, you have the value. The output is not the resultant image. Resultant image mean like you have image, process, you get good image. But this one, you have image, you process, you don't have, the output is not image, but the output is a control, a machine, for example, right? Open the door, all right? Give alarm, for example. So that is not the resultant image. That is the numerical data. Numerical data means that the process, you need to have some value to do what? To perform what? To run the machine, something like that. Okay, so this is a level of image processing. Fundamental step in image processing: manual interpretation, computer-based interpretation. So computer-based is image processing or computer vision system. But then this is a comparison with manual. See, manual means that human beings are highly skilled in recognition, but slow in performing numerical calculation. Computer are very accurate in performing numerical calculation, but less skilled in recognition compared to human being. Less skilled, but we can train to become sometimes outperform of human decision. Human beings are affected by many factors such as fatigue, boring, lazy, uh, the not stable. Human errors are inevitable. Computer robust. Then you can read the rest. So this is step in image processing. If you have an image, you want to process it. This is the object. You acquire image, enhance image, segment image, future abstraction, and you perform pattern recognition to recognize the object. Okay, so I think that's all. I will continue on the part 2. Thank you. See you again. Bye bye.